Other sine and cosine graphs. From section 1, we are aware of the shape of the graphs y equals sine of x and y equals cos of x, so from 15.1, and their important properties. It is also possible to construct the graphs of other sine and cosine functions, either by constructing a table of values or by analysing their properties. In general, sine and cosine curves are referred to as sinusoidal curves. A sine wave, or a sinusoid, is a mathematical curve that describes a smooth, repetitive oscillation. On our course, we have to consider graphs of the form y equals a plus b sine of cx and y equals a plus b cos of cx, where a, b, and c are elements of the real number set. Each of the constants, a, b, and c, will have an effect on the shape and location of the graph, and on all the features outlined in section 1. We will examine each of these in turn and refer to the transformations that produce these changes. So this is a summary of all the factors that we're going to learn about in the next few videos, all to do with sine and cosine graphs. So consider the sine graph y equals a plus b sine of cx, and the cosine graph y equals a plus b cos of cx, where a, b, and c are constants and c is greater than 0. These graphs have the following properties. So the midway line is going to be y equals a. So whatever that a value is, the midway line will be y equals a. The orientation will be normal if b is greater than 0. So if the b that's stuck on in front of the sine or the cos is greater than 0, it's normal. It's inverted if it's less than 0. The amplitude is going to be the modulus of b, so the positive value of the b, whatever is stuck on in front of the sine or cos. The range is going to be a minus the modulus of b, so the a value that's in front minus the modulus of b, comma, a plus the modulus of b. The minimum is going to be a minus the modulus of b, and the maximum is going to be a plus the modulus of b. And the period will be 360 degrees divided by c, so whatever number is stuck on in front of the x, the period will be 360 degrees divided by c, or 2 pi divided by c if you're dealing with radians. So we're going to look at these in a lot more detail now in the next few videos.